Hi there. This is a call to startups. I'm not selling anything, and I'm not looking to start my own business. I'm here to share an idea for addressing a major challenge in the world of scientific and related literature. The world is being flooded with scientific publications, science-related texts, such as essays and other high-quality content. No one can keep track of it all, and no one can read everything published in their field of interest or expertise. As a result, many innovative and original ideas go unnoticed. This can't go on. It's getting worse and worse. But there is a way forward. Artificial intelligence operates through statistical pattern recognition. In other words, it calculates the probability that a given word, or more precisely, a token, will appear next in the text. This principle can also work in reverse. The less likely a word is in its context, the more original and potentially innovative the text may be. Or, of course, the more nonsensical. Originality, the ability to think outside the box, has always been a powerful driver of progress and innovation. Based on this, we can rank texts by their degree of originality. Such a ranking, however, must be complemented by additional parameters. The most important parameter is the predictive deviation score, PDS. This is also called the deviation index or the creative divergence index. It indicates how far a text deviates from what is statistically expected. Let's break it down in simple terms. An AI is trained on millions of texts and learns which words usually follow one another. It then becomes quite good at predicting which word, or more precisely, which token, is most likely to come next. Now here's where it gets interesting. If a sentence is exactly what the AI expects, it's predictable, and usually a bit boring. But if a sentence suddenly uses words or turns of phrase that almost nobody would put together, it's at least unusual. The predictive deviation score measures precisely this deviation from the expected. A high PDS means the text often surprises the AI. That could mean it's highly original, maybe even brilliant, or it could be complete nonsense. A low PDS means the text follows familiar patterns, likely solid, but not particularly new. Why is this useful? The PDS acts as an originality detector, but it needs to be combined with other evaluation criteria to filter out nonsense. The PDS also includes a novelty detection component that goes beyond token-level statistics. It uses semantic distance in a vector space model, allowing it to detect original structure, even when the wording itself is conventional. But that's already getting into the technical details. The second most important parameter is the nonsense score, divided into categories U1 through U5. The U comes from the German word Unsinn, nonsense. U1 means logical inconsistency. It measures to what extent a text is internally illogical. U2 means semantic incoherence. It indicates how erratically the text shifts between semantic domains or meaning contexts. U3 means structural emptiness. It captures the extent to which the text contains filler words, empty phrases, or hot air without substantive content. U4 means discourse connectivity. It measures how well the text fits into a recognizable field or domain of discourse. U5 means ideological load. It assesses the degree of ideological bias in a text. This is particularly relevant for humanities-related writing, as many readers prefer to avoid overtly ideologically charged texts. I already have a concept for detecting ideological content, but it has not yet been adapted for AI implementation. All of these parameters can be extracted from a text by an AI and stored in a database. The database contains, in addition to the basic metadata of the text, such as title, author, source, publication date, fields of study, topics, keywords, and so on, the computed parameters as well. Through a graphical interface, users can filter the texts according to their interests and have them displayed in a ranked list based on a predefined weighting of these parameters. Personalization will, of course, be possible. The language coverage should include those languages that an AI typically handles very well. At present, these are English, German, French, Spanish, Italian, Portuguese, Dutch, Polish, Russian, Mandarin Chinese, Japanese, and Modern Standard Arabic. However, Chinese, Japanese, and Arabic require a specifically trained AI model. For this reason, it may be advisable not to include these languages in the initial rollout. A web crawler is not planned. That would be too complex and potentially pose legal pitfalls. Instead, AI-assisted creation of a table containing sources that typically provide high-quality texts, platforms such as Archive, ResearchGate, academia.edu, as well as journals and newspapers, various blogs, academic websites, and so on. If the source is not public, access will be negotiated with the operators. Authors can also submit their texts directly to GeniusRanker or link to it. A special feature is the translation index. An AI can calculate a translation index for each text, indicating how well it can be translated into another language. This translation index is stored in the database as a matrix. The translation index provides the user with an indication of whether it is worth having a text automatically translated into their preferred language. An important question, of course, is how to make money with it. Well, you can do it just like the rest of the world does, either through advertising or a subscription model, or a combination of both. Now a few words about me. My name is Hans-Jörg Pfister. I have 35 years of professional experience in software development and a master's degree in philosophy, political science, and comparative religious studies.